Hello and welcome to the section 6.2 lecture. Today we are going to be looking at converting line forms. So we kind of mentioned this the other day that yes, we can write things in slope intercept form, and that's our favorite one because it does have so much good information. Today we're going to look at, well, what if we're not given it in slope intercept form? And really the main job today will be okay, let's turn it into slope intercept form just so we have that and we can use that. I am going to have you do some other conversions as well, just to keep working on those skills. So just kind of a review to start with, the different forms of linear equations. We have slope intercept form, we have point slope form, we have vertical lines are x equal a number, horizontal lines are y equal a number, and then standard form. We have ax plus by equals c, where a, b, and c are real numbers. And we're going to say even more specifically on that, wait a minute, more specifically on that, I'm not going to write it, but you can just take it for what it's worth, that a, b, and c have to be integers, okay? So, or whole numbers, if you will. And then we'll talk about some other weird things that happen with that. So, and a and b are not both zero. Because if a and b are both zero, you'd have 0 equals c, and that would be weird unless c was 0. So let's see, there's four main conversions that we're going to talk about today. We're going to talk about point slope to slope intercept form, point slope to standard form, slope intercept form to standard form, and standard form to slope intercept form. A lot of weird stuff going on, a lot of conversions to be done. But the main things that you'll notice is that we're trying to turn things into slope intercept form and standard form. Okay, I'm letting you off a little bit, not making you, and I do say making you because that's what it turns into. Turn things into point slope form. That one's not quite as easy. It's not as easy to turn something in slope intercept form into point slope form, mainly because there's a lot of different ways to do it. Okay, but yeah, we're not going to focus on that. We're going to focus on these. So converting to slope intercept form. So we're trying to get this into y equals, actually since I kind of did it in red up there, let's do it in red here. So we're trying to get this to be y equals mx plus b. All right, so when I'm looking at this equation and I want to end up with y equals mx plus b, okay, really what it comes to do in this, and I'm not going to have this down here because it might not end up right there, but really the only difference is that there's no parentheses and that the y is by itself, okay? And so I'm going to have some things that I'm going to be writing on here that are kind of weird, and we have to remember what they are and how that works. So the biggest thing we have to remember is that the basic form y and x are variables, and those are going to stay variables. All right, so let's go and see what happens when we first do our distributive property. So m times x minus m times x1. Keep in mind that m, x1, and y1 are all numbers, okay? And then the last thing we have to do is move this y1 to the other side because that's a number that's on the same side as y, and we want to get rid of that. And so I'm just going to add y1 here on the end. And we get, over here, my y1's cancel, get y equals, we wanted mx plus b, right? So we get mx. And sort of the quickest way to say it is I'm actually going to make this a positive and then a minus mx1 plus y1. So that's how I took care of that negative, was just to put it in parentheses. Now, it turns out that with any slope or any point slope form, you can find your y-intercept. It's the opposite of m times x plus y1. That's what turns out to be your y-intercept every time. I should say m times x1. Again, m is a number. My slope is always given to me as a number. My x1 is always a number. It's the x-coordinate of a point, and the y1 is also always a number given to me as a point. So we would have now mx plus b, and just kind of the little caveat we have is that where b is equal to negative mx1 plus y1. You don't really need that, but the process is all the same, right? We distribute and then we move our y1 to the other side. Here I had to add it because it was the minus y1. That might be a plus sign right there, so you might have to subtract it. Okay. From standard form, I want to get it into y equals mx plus b. So I want to get y by itself. I'm going to subtract ax to move that to the other side. And so on this side that cancels. Over here some weird stuff happens. But I get by equals c minus ax. Actually, I'm going to write that a different way. I'm going to keep the ax in front. So minus ax plus c. And then the last thing I have to do is to divide by b. I'm going to divide both sides by b. And when I do that on the left, the b's cancel. That's what I wanted. So I got y equals. That's the main part of slope-intercept form. And on the left side, I have a couple things that I have to do. I want to, what do I want to say? I want to split that b up. And I'm just going to write it that way. So I'm actually going to erase what I had. I'm going to write it that way. If you want to, you can. If you don't want to, that's okay also. All right. Now this part should look familiar. When we graphed in standard form, we said that the y-intercept was always our c over our b. It came from the cover-up method. The other thing that we could have talked about in standard form was that the slope is always the opposite of a, so negative a, over b. And that's what's going to give us our slope right here. So we have negative ax, or sorry, let's say negative a over b, x plus c over b. And that's written in mx plus b form. All right. So my slope is negative a over b, and my y-intercept is c over b. And so you could just jump to those. I kind of have that feeling of, yeah, you could. Why don't we just do the math, though? Okay, what's the harm in just carrying out the operations with the numbers? So the first thing I'm going to do on this first one, I have it in point slope form. I want to get to slope intercept form. I want the y by itself. And if the first thing you think about doing is adding 4, even though it wasn't the first thing I did up there, that's okay. The only tricky part is that I can't add the 4 to what I have here. Okay, this would just turn out to be 1/2 x plus 3 plus 4. I can't say 1/2 x plus 7. Okay, because that 3 is really already changed by the parentheses and the number outside. So I'm not going to say that. I'm just going to say that what we should do is distribute first, and that'll show us why it's not the same. 1/2 times x is 1/2 x. 1/2 times 3 is 3/2. And so right there, it's not 3, it's actually half of 3. Now I can go ahead and add 4 to both sides, and this time I can add 4 to that 3/2. We'll talk about how to do that. Over here they cancel. I get y equals 1/2 x. And then I have 3/2 plus 4. 4 is actually 8/2. 3 plus 8 is 11, so that's 11/2. So 11 over 2. Awesome. Okay. So That is our equation in slope-intercept form. Our next one, we have 6x minus 3y equals negative 12. We'll go and subtract 6x from both sides. That's what I did before. And so I have negative 3y equals, I'm going to sneak that negative 6x in at the start. And then I'm going to divide by negative 3. And again, I'm going to do it under each term that I have over here on the right, as opposed to just dividing the whole thing by negative 3, and there is no difference. That is the same thing. And that just comes from, if we saw it before, we had that minus ax plus c over b. The reason it's equal to this is the same reason that it's sort of the backwards version of adding fractions with common denominators. Here we have common denominators, we can write it this way. If we can do something, odds are we can do it in the reverse order also. So I just split it up into those two, and that's what we have. Negative 6 divided by negative 3 is 2. Negative 12 divided by negative 3 is positive 4. And there we go. All done. Awesome. Let's look at the next page. We want to convert to standard form. So we want this to look like ax plus by equals capital C. And let's see how we can do that. Actually, these should be blue. Wrote them as blue on the previous page. So what does that look like compared to what I have? Well, the only difference is that x and y are on the same side. Okay, they're being multiplied by a single number, and they equal a single number. So we need to get it into that form. So from point slope form, my main goal is to move x to the side that has y. And then we'll do that first and then see what we can do from there. But I'm going to start by distributing. So y minus y1 equals mx minus mx1. Okay, now I want to move my mx to the other side, so I'll subtract that. There are no x terms on the left side, so that's just going to be what we start with. And then plus y minus y1 equals negative mx1. Still, I want to get x and y on the same side, so I'm going to be moving this y to the other side, this y1 to the other side. Negative mx plus y equals, I should say I'm adding y1 to both sides, stay consistent, negative mx1 plus y1. Okay, ugly, yes, but I do have a number times x, technically a number times y, and since these are all, this is mx1, since these are all numbers, they would combine to give me just one number. These are just constantly harder to do when we have things in letter form, but easier once we have numbers. So bear with me on those. We'll see what happens. The best one is going from slope-intercept form, because my goal is to get x and y on the same side and a number on the other. That's pretty straightforward. If I subtract mx on both sides, on the right side they cancel, the left side they're hanging out there. Plus y equals b. Okay. So let's look at the these actual examples that we have. And we'll follow the same strategy. The first thing I want to do is to distribute that negative 3. So we say we have y plus 15, negative 3x. Negative 3 times 10 is positive 30. So I'm going to start by adding 3x. So here you can see, like this right here is is my m times x1. It was ugly up above, but here it's just a single number. So over here, the 3x's cancel, and I get 3x plus y. Oops, we still have our plus 15 there. Plus 15 equals 30. Now I want to move that 15 over. I'll subtract 15. And 3x plus y is going to be equal to 15. I have x and y on the same side. They equal a single number. And again, this is that negative m1, negative m x1 plus y1. Right? That's just what it is. Okay. And I don't really consider that to be a hard set rule because of things like negatives that can get involved and all those. So I just say, let's work out the problem and see what we get. We get 3x plus y equals 15. Next one, I've got slope-intercept form. So like I said on that one, all I want to do is move that x over. So I'll subtract 1/5 x. And here's where we run into a little bit of a problem. I get negative 1/5 x plus y equals negative 12. And part of this is pretty widely accepted. The other part, the jury is still kind of out on, right? There's no hard set rule, but we could make one if we wanted to. I'm going to on this one just because I think it does look better. So here's the deal. First of all, I can't have any fractions here. So I have to do a process that's going to kill my fractions. It's going to get rid of every single fraction. Thankfully, I only have one. And the way that I get rid of a 5 in the denominator is that I multiply the whole equation by 5. Now, where the jury's still out is, can we start with a negative? And kind of not. Sometimes you can, sometimes you can't. And believe it or not, there's always a way to make sure that we start with a positive. So to make this first term a positive, I'm going to change all the signs eventually. But what I do is I have to multiply this first term by a negative. Whatever I do to one term, I have to do to everything, just to keep the balance and make sure that everything stays good. So it turns out that I'm going to multiply this whole thing by negative 5. Negative 5 times negative 1/5 is just 1. So that's going to turn into x. Negative 5 times y will be minus 5y. And negative 5 times negative 12 will give me positive 60. So you notice I'm starting with a positive. That I'm not going to say is 100% necessary, but I like it. I think it does look better. Even if my other two had to be negative, it just looks better to start with a positive. Okay? And it's helpful further down the road when we do some other things. And then the big thing is that I don't have any fractions in here. There's always a way to get rid of every fraction in any problem that you have. Sometimes you're going to make your numbers a little bit uglier. Like in this one, we turned a nice, easy negative 12 into positive 60. That would be tougher to graph, but it is the proper way to do it. So that's what we get there. And now for these ones, we want to convert them into all 3 line forms. Okay? They're what we call kind of in no specific form, and we want to turn them into all 3. And so the 3 that I'm talking about is standard, slope-intercept, and point-slope. So here we will be doing a little work to put it into point-slope form. Okay, let's start with standard. Then move to slope-intercept, I don't know why I'm writing this twice. I just didn't write those ones in the right spot. And then finally point slope. That one will be the harder one. To turn it into standard form, I just need x's and y's on the same side, and I need them to equal a number. So the way I'm going to handle that is, I guess I'll rewrite it every time too. That's going to cut down a little bit on the room that I have, but to do that here, I'm just going to subtract 2x from both sides. Okay. Subtracting 2x on both sides gives me 3x plus 3y equals -5. And we're done. Now, to go into slope-intercept form, you can either take what you already had, or take what you were given, or you can take what you came up with. It doesn't really matter. Since we worked on standard to slope-intercept form, maybe that makes a little bit more sense. But I'm going to pretend like we didn't start by doing standard, and I'm going to try to revert back to the original. So in the original, I don't think that this is the easiest way to do this. But if you wanted to start with slope-intercept form, this is how you would do it. I'm going to subtract 5x from both sides. Bam, bam. And I get 3y equals -3x minus 5. And now I need to divide both sides by 3. Divide by 3, divide by 3, divide by 3. So then y equals -1, or just -x, minus 5/3. And that's good to go. Now the last one is really not nice. So I've avoided it in a lot of situations. But I want to turn this into point slope form. So let's maybe do it on this one and maybe not the second one, just to make our lives a little bit easier. I guess there's an easy way. Not really. That doesn't work too well on that one. Yeah, let's just see what we can do. The biggest trick with point slope form is that I need both y and x to be to not have a number in front of them. Okay, so I guess there is an easy way, and let's go with the easy way for now. All right, I need it to look like y minus a number equals a number outside of parentheses, and then x minus a number. I don't know why I use 0. I may end up using 0. So let's just say minus a number equals, more specifically, this m has to be the slope. Well, the slope is -1. So that's what we're going to use. So my slope is -1. Okay. And now I need to fill in numbers in the other pieces. Okay. That's not too hard, because if I use this equation that I already found, this left side is really just y minus 0. So that can work. Equals -1 is the slope, and all I'm really doing there is I'm factoring a -1 out of this side of the equation. Or in other words, dividing -1 by both of those pieces. And since there was no requirement that nothing in here could be a fraction, I'm going to stick with the 5/3. Okay. When I ask you to do this at other times, I'm going to give you some points. Okay. And we could have done that. We could have plugged in a value for x, found out what y was, and then just used that point. That would be okay as well. All right, but an easier way, just use the slope-intercept form that you have and factor out whatever you can. And sometimes you might not need to factor anything out. But if this is like a 2x, then you'd have to factor out a 2 because this number needs to be the slope. The slope's -1, so it needs to have a slope of -1. Okay, we're just going to do standard and slope-intercept on this one just to keep the time down a little bit. So for standard, let me switch colors just to make it, I'm going to be encroached on by my other problem. Standard, it's pretty close. It almost has x, y on the same side and a number on the other. It's got an extra number here. To deal with that, we're just going to add 7 to both sides. So I have 4x minus y equals 7, and we're good to go. Okay. For slope-intercept, slope-intercept form, I'm going to take the one that I already had. It is easier. I'm going to use this. And I'm going to move the 4x over. I do want to get y by itself. Oops, that's a -4. So -4x. And again, I'm going to slide that in the front there. So those cancel. I have -y equals -4x plus 7. And the only tricky part here is that I can't have it be -y. I need it to be y. Well, the way I deal with that is I just take the whole equation and multiply it by -1. It's just going to switch the sign on everything. -y turns into +y, -4x into +4x, and +7 into -7. And we're good to go. So I guess kind of lying on the point slope idea, again, using the one that I already have, because there may become a time that you have to do this. We're looking at y minus 0 equals 4, my slope, and I have to divide that from, too happy with that, divide that from both the 4x and the 7. So it's going to be 4 times x minus 7 over 4. So that's how that looks. Okay, because think if you multiply this through, you end up with your 4x minus 7. Okay? Now let's look at practice problems. The ones I expect you to do, we're going to practice. I want you to, kind of similar to the time before, let's say pick 3 per section. So I want you to do 3 of 1 through 6 and 3 of 7 through 12. And then for application, I've already looked at it, but we will in a second. We're just going to go with number 1. Okay. Number 1 is converting this graph into the 3 different forms. So that's not as bad as what I said about point slope because you have points that you can pick. Okay, so once you have your slope, point slope, and a line, your point slope form's pretty easy to find. Okay, so that being said, make sure you get that done, get a good score on your mastery challenge, and we will see you in class.